Okay. Powers are used to represent. Please highlight, underline, put a Mrs. Bad Crumble cloud around it. I don't care what you do, but please understand that it is repeated. I know that you know that 7 to the third means 7 times 7 times 7, which is 343. I know, Ojos knows that you know that. But at some point in this unit, at least one of you is going to say that 7 to the third is 21. You're going to do it. You're looking at me now and saying, it's not going to be me, man. I'm not that. No way. What kind of idiot would say that? And you're all thinking it. This is the 20th year I have taught exponents to kids your age. Every year, from essentials math to pre-diploma math, there is a bunch of, that's 21. It will happen. When it happens, I will do this. Mm-hmm. And you all will go, and I will be blamed as being a bully. I'm just covering it now. I will go, mm-hmm, and that will be it. Sometimes a kid likes to get it out of the way early and does it on purpose. Or they tell me they've done it on purpose. That's a lie. But that's okay. All right. Now that that's all covered, let's get back to business. Here I have a mathematical expression. That mathematical expression has 3 different things in it. The first of those things is the base, which I'm going to highlight in green. Where is the base? It is the 7. Abso-smurfly correct. This is where we possibly diverge from what you learned in the 9th grade. Technically, in the 9th grade, all the work you did only had to deal with numerical bases. Technically. You're in the honors class. I assume that you saw this. Did you? Excellent. There is no difference. In this case, it is a 7 is the base. In this case, it is an x is the base. I can have anything for a base. The important thing here is to know that a base is anything. Anything raised to an exponent. And the other important thing to remember is this. It is only, and again, highlight Mrs. Bad Crumble cloud, don't care what you do, only the expression directly to the left of that exponent. So, what do I mean by that? In this white space right here, I'm going to write a couple of things. You don't need to write it. You can just pay attention, or you can write it. I don't care. Q squared, Q plus X squared, 3Q squared, and 3Q squared. What is the base here? Q. So what is the only thing that is being multiplied twice? Just Q. Good. What is the base here? Q.
I saw it as Y.
That's fine, Hazel. It looks kind of like a Y. It could also look like a G, but it's a Q. What's the base? Q. So what is the only thing that is being multiplied? Just Q. What is the base here? 3Q. How do those two differ? The brackets. What is the job of brackets in mathematics? To group stuff together. Because these brackets are holding the 3 with the q, and that whole thing is to the left of an exponent, that whole thing is the base. What about this one? Just x. So it is q plus x times x. Everybody good? A great many of you are looking at me. Yeah, duh. Trust me, there's a reason. The exponent I will highlight in yellow, which is right there. What is the exponent? The number of multiplications for the base. All right. Exponents are all about the base. You knew that was coming. If you didn't, you don't know me very well. All right? So, you must be aware that no matter what is in the base, it is going to repeat as many times as the exponent does. All right? Excellent. The power is the whole thing. The power is not an base, you idiot. A base and an exponent. And we read that as base to the exponent and then erd. Or orth, or ifth, right? So this guy would be 7 to the third. Some exponents have special names. What are the only two that have special names? Squared, x that is x squared, and x that is x cubed. After that, we just use the number. Everybody good? Great. Now, every single one of you has the skills and knowledge to fill in this chart by yourself. Not by yourself, but without me. You can talk to your neighbor because there are some tricky ones on there. Everybody good? Go. Do your best. Check your work. The first one that people usually screw up is right there.
Is the red answer the right answer?
No, they're both. Can anybody explain why the yellow line is what it is? The negative sign has not been included in the base, has it? So what is the only thing that repeats? The 3. 3 times 3 times 3 is 27. But there was a negative out in front of it all. So the final value has to be negative. Everybody good? All right. The next problem people face is they don't remember how to do that with their calculator. To do those with your calculator, it is base. Then you must hit, there are 4 buttons that it might be. It might be a button with a Y and an X up there. It might be a button with an X and a Y up there. It might be a button that looks like a little mountain, which is called a caret, C-A-R-E-T, not what's up, Doc? Or the newest one I've seen, and this is the one that makes me cry, an X with a little blank up there. Because kids are getting so bad at math that we need to draw what it looks like instead of using X's and Y's anymore. It's one of those 4. And then you hit the exponent. And then you often need to hit equals, but not always. The next one that kids screw up is this one. -1, -1, -1, -1, -1, -1. Why is it -1? Because the negative is part of the exponent, so the negative has to repeat. And since it repeats an odd number of times, you end up with a negative answer. Cool? All right. Everyone is good with 1,000 usually. Why is there no number there? Because you don't know what x is. X is just some value. So you cannot evaluate it. This one is troublesome. How does positive 2 repeated 5 times get to a negative? There has to be a negative out in front. And that negative isn't repeated. Now, why this is problematic is because of this. -2 to the 5th equals -32. But so does -2 to the 5th. Why? This is what you have. Does everybody understand the purple line there? 2 times 2 times 2 times 2 times 2 is 32, and then it's negative out in front. This one is -2 times -2 times -2 times -2 times -2. What's -2 times -2? Positive 4 times -2? -8 times -2? Positive 16 times -2? -32. That's why these are both true. And that is the beginning of why exponents cause you guys problems. Is everybody cool? All right. Now, you will notice in the next line, I've done it in black and red. They are both correct. To get the positive 9, I could do 3 squared, 3 times 3. Or I could do -3 squared. -3 times -3 is positive 9. Everybody cool? The other way I could get to 9 is 9, not repeated at all. 9 once. 9. No repetition. And then this one always causes trouble because of the double negatives, right? The negative repeats how many times? 6, which is an even number, right? So the answer is positive, 4,096. But what does that negative tell you? That everything after it is going to be opposite, right? What if that exponent was 7? Would this be a positive or a negative number? Positive. Everybody good? Excellent. And then the last one's easy. Are we all good? Okay, turn the page over and let's review the 9th grade. Please, please, please actually go through this as if you don't know what you're doing. There's a reason. Multiplying powers of the same base. All of you already know this answer. 2 squared times 2 cubed is what? 2 to the 5th. You all already know that because you have memorized that step, right? It is infinitely more important from here on to know why that is true. Why that is true is because 2 squared is 2 times 2, correct? Then times 2 cubed, 2 times 2 times 2. There are 5 repeated numbers, so it is 2 to the 5th. Right? And then we write down the rule, which is x to the m times x to the n equals x to the m plus n. That's the rule. The reason I am taking this time over here is because in the 9th grade, most students only do one law at a time. In the 10th grade, all 7, the next 2 pages, can be in one question. That's why I'm doing this way. And I know it seems tedious, but I also know I need to do it. Next one, dividing. 2 to the 3rd divided by 2 squared. That's the same as 2 to the 3rd divided by 2 squared. And what is the answer? 2 to the 1. Do we ever write 1? No. Why does that work? Because that is 2 times 2 times 2 over 2 times 2. 2 over 2 is 1, so it cancels. 2 over 2 is 1, so it cancels. And I'm left with 1, 2. Easy peasy, right? How do we write it out in good math language? X to the m over x to the n equals x to the m minus n. And we are all good, yes? Of course we are. Raising an exponent to an exponent. That is this. 2 cubed squared. What is the answer? 2 to the 6th. Why? Because it is 2 cubed times 2 cubed, which is 2 times 2 times 2, times 2 times 2 times 2, which is 6 2s. Easy peasy, right? X to the m to the n equals x to the m plus son of a times n. Yeah? Those are the easy ones. They're easy to illustrate. Everybody's cool with them, yes? The 4th one is the one that starts screwing people up. 7 to the 0 equals what? No. 1. Oops, I should have written that in black. What do you have now? Oh, so you have number 6 there. No problem. Let's do that one. A fraction base. 3 over 5 squared. What does that mean? What is the base? 3 over 5. How many times will it repeat? Twice. So it is 3 over 5 times 3 over 5, which is 3 squared over 5 squared, which is 9 25ths. Right? Now that is very closely related to the 3rd law, isn't it? So the rule is x over y to the m is xm ym. The m goes to everything. Now, can I ever forget the other laws? What I mean by that is, let's say you leave Canada, right? Can you murder someone? No. Why not? Because it's against the law. Where? Everywhere. You cannot forget the laws that you already know. Keep that in your head. What is your next number? Now we're back to exponent of 0? Okay. 7 to the 0 equals 1. Right? Okay, what is 9,732 to the 0? 1. What is... We'll stop there for a moment. Let's explain why. Everybody cool? Watch the explanation. It's a little weird. 7 squared divided by 7 squared. What would you do with those exponents? Just like law 2, right? 7 is 2 minus 2, which is 7 to the 0, yes? Everyone agrees? Okay. Now, what is this value? 49 over 49. 1. 49 over 49. Same thing on top and bottom of fraction is 1, yes? Everybody agree? So, if 7 squared over 7 squared equals 49 over 49, and it equals 1, then what does that tell us about this? That 7 to the 0 must also equal 1, yes? Now, if that happens in math, math is lovely because it always makes sense. If it happens once in math, how often does it happen? All the time, right? Okay, so then you should all be able to tell me what negative 7 to the 0 is. 1, because everything to the 0 is 1. Then you should all be able to tell me what negative 7 to the 0 is. What is it? Negative 1. What? Why? Because 7 is the base here. Here, the negative is part of the base. Okay? Does everybody understand that very subtle difference? If the negative's included, it's still 1. If the negative's not included, it's still 1, but it's negative. Good? Is your next one 5? Okay. Now you'll notice in this one, I can't do it with just numbers, right? It's impossible. So I got to go straight to the letters. But you're intelligent young people. If I had x squared times y squared, I would get x squared y squared, right? Okay. Well, this is just x, y squared. The x is squared and the y is squared. The exponent goes to everything. Can I forget any other laws? No, I have to remember all of my other laws. So the rule here is x, y to the m equals xm, ym. But I can't forget any other laws. So what if I had this? X squared y cubed squared. What would that be? X4, Y6, because I can't forget law 3. Everybody cool? Okay, what would this one be? 3x squared squared. 9x to the 4th, because that 3 is part of the base. Everyone cool? Okay, what about this one? What's that one? Is everybody good? Yeah? Everyone's cool? Sweet. And now we come to the true death of grade 10s, no matter how brilliant they are. Negative exponents. Hopefully you've all seen it. If you haven't, pay very close attention, because this messes kids up, and I really don't know why. I'm going to start with the easiest definition I can think for it. What is 2 cubed? Really? 2 times 2 times 2. And what is that value? 8. Easy peasy, right? 2 squared. What is that really? 2 times 2. I have removed one multiplication, yes? What is the opposite of multiplying? So this is 4. So what math happened here? I divided by what? 2, because that was my base. Everybody cool? What's 2 to the 1? 2. Divide by 2. And what do I get? 2. Logically, what's the next exponent? 2 to the 0, which we know doesn't have 2 as a base anymore. What's its value? 1. We know all that, yes? Now, what have you just seen? This is repeated thrice, yes? If something repeats thrice in math, what will happen? It will continue to repeat. So logically, what is the next exponent? 2 to the negative 1. Okay, so what does that mean? That means 2 multiplied negative 1 times. Does that make any sense? No. But this continues. What is 1 divided by 2? 1/2. What is the next logical exponent? 2 to the negative 2. Divide by 2. 1/2 divided by 2 is 1/2 times 1/2, which is what? 1/4. So this is 1/4. Now please notice there is a pattern here. 2 squared 4. What is 4 really? 4 over 1. 1 over 4. 2 to the 1 is 2. What is 2 really? 2 over 1. 1/2. You're intelligent young people. What therefore must 2 to the negative 3 be? 1/8. 2 to the 3 is 8, because 8 is really 8 over 1. Is everybody good? Now, some kids don't see this from this pattern. That's cool. I'm okay with that. I got another thing to show you. But we're out of time. We'll stop there. No homework. You're relaxed.